Use the distributive property to write an equivalent expression. For this lesson, we're going to use the distributive property. And remember, to distribute, you take whatever's outside the parentheses and you distribute it to every term that's in the parentheses. So in this case, we take the 4 and we multiply it by each of the 3 terms. So you're going to rewrite it as 4x plus 4 times 4 plus 4 times 6y. And then you can do your multiplication, and that will be an equivalent expression. So you have 4x, so we don't need to change that. The 4 times 4 we can change. And remember to keep all your plus signs in between each term. So 4 times 4, that'll give you 16. And then 4 times 6, y, which is 24y. Okay, and that's your equivalent expression. And so we just use the distributive property there. Now, in some cases, you're going to have like terms. And what it means by like terms, well, first of all, what is a term? Well, each thing in the parentheses, which is separated by the plus sign, is a term. So the x is a term, the 4 is a term, and the 6y is a term. And then after you use the distributive property, then you're left with 3 terms. You have the 4x, which is a term, the 16, which is another term, and the 24y, which is another term. So each of those are terms. So examples of terms could be like 2a, 32x, 5, any of these. But what isn't a term would be something with a plus or minus sign. If you have 2 terms, it's going to be separated either by a plus or a minus. So 2x plus 5, that whole thing is not a term. That's actually an expression that contains 2 terms, the 2x and the 5. And what it means by like terms is that's when the variables come into play. If you have 2 terms that have the same exact variables or variable factors, they're called like terms, and you can combine those. So an example of this could be 2x and 3x. Okay, you don't look at the number to tell if it's a like term. You look at the variables. And in this case, they both have an x. They both have an x and exactly just one x. They don't have an x squared or an x and a y. They each have the same exact variables as factors. So those are like terms, and you can combine those. So you can just add the numbers. So 2x plus 3x will give you 5x. So that's what's called collecting like terms, is when you actually add them together when they have the same variable factors. Okay, another example of that could be 2x squared minus x squared. Okay, and we want to collect like terms. And so this, you would and with the x squared, you can imagine that there's a 1 in front of it. You don't need to show that there's a 1, but for this example, just when you just have the variable by itself, there's always an invisible or assumed that there's a 1 in front of it. So in this case, it's 2x squared minus 1x squared, or just minus x squared. And so you just subtract the numbers. So 2 minus 1 will give you a 1 x squared, or you can just write it as x squared. And that would be combining like terms with that example. okay, or collecting like terms. So here's a couple more where we collect like terms. You have a 6y and a 3y. So to collect like terms, you're just going to add the 6 and the 3 and get 9y. Okay? And then the next one, now you have 3 terms, but notice this middle term has a y. It doesn't have an x. So to collect like terms, you're going to add the 2 terms that have x's as the factors, as the variable factors. You're going to add those together. So a 2x plus a 3x will give you a 5x, and then you still have the 2y. So we collected the like terms, and you still have one term that didn't match any of the like terms. So this would be your answer if it said to collect like terms. Okay, this last one is very similar. And we have an x squared. Here's another x squared. But then we have just an x. So to collect the like terms, we're going to collect the x squareds. So we have a 2x squared, and then we have another 4x squared. So we add the 2 and the 4, and we get 6x squared. And then we still have the 3x. Okay, so that's what's meant by collecting like terms. Is you look for, well, you look at each term and you kind of match up the variables. Now sometimes you'll have more than one variable attached to a term. You can have, let's say, 2ab. That would all be one term. Since it's all multiplication, that's all one term. But if you add a 2a to that, these are not like terms because the first one has a b and the second one doesn't. So they have to have the exact same variable factors. However, if you have one that's, let's say, 3xy plus 2xy plus 2x squared y. Okay, if you look at all 3 of these terms, only 2 of them are like terms. The first 2 are like terms, but in this third term you have an x squared, so you can't combine that with the other 2 terms. So in this case you would just be combining the 3xy and the 2xy. And that'll result in a 5xy. And then you still have this other term at the end, which is 2x squared y. Okay, so that's combining like terms.